Welcome to Spring LIB.
In this question, given data is that is there are two blocks given and the mass of both blocks is equal, that is equal to given, that is m is equal to 2 kg. And now in the question it is saying that the first block is having speed that is 2 meter per second and collides with the another second block which is initially at rest condition. That means here I will draw the figure so that you can explain the data. So this is a ground, and consider that this is a first block and this is a second block having mass as its same, that is equal to 2 kg. So now this first block is taking a collision by given speed that is equal to initial speed, or I can say that is equal to 2 meter per second, and collides with this second particle which is initially at rest condition. So after collision, then in the question it is asking that here we have to solve two parts. So in the first part it is asking that we have to find maximum possible loss in kinetic energy due to collision, and in second part it is saying that is actual loss in kinetic energy is half of this maximum possible in kinetic energy. Then we have to find coefficient of restitution. So that means in part B there is a condition given, that is if actual loss in kinetic energy is equal to half of maximum possible loss in kinetic energy, then find the coefficient of restitution. So now let's start answering this question. So here first I will solve part A, then after it I will try to answer the part B. So in the part A we have to find maximum loss, possible loss in energy, kinetic energy due to collision. So here first I will write the given data in answer, that is mass of first block and second block is given, that is first block having mass, I can say that m1 is equal to 2 kg, and mass of second block will be, that is m2 is equal to, that is 2 kg. Now here the initial speed of first particle is given, first block is given, that is v1, that will be equal to 2 meter per second, and initial speed of second block will be, I can say that 0 because it is at rest condition. So I can say that initial speed v2 for second block will be, that is equal to 0 meter per second. So now for getting the maximum possible loss in kinetic energy, we have to consider that first collision is elastic and linear elastic, and after collision both blocks are moving at same velocity, that is assume that is v. So moving with final same velocity, that is v meter per second. So here we have to consider these 2 points to find the maximum possible loss in kinetic energy. So maximum possible loss in kinetic energy will be written as, that is equal to, first write the kinetic energy in initial condition. So I can say that it will be written as half m1 v1 square plus 0, because this is a kinetic energy of first block and this is a kinetic energy of second block. So kinetic energy of second block is written 0 because it is a initially at rest condition. So now I can say that here I had write the total kinetic energy in the initial condition, and now I will write the total kinetic energy after collision. So it will be written as, that is half m1 v square, in the parenthesis I can say that half m1 v square plus half m2 v square. So now next step is, I can say that this is a equation number 1. Now next step is, here I am applying a law of conservation of momentum, linear momentum, to find the final velocity v, and substituting this value in this equation number 1. So here first the next step will be apply the law of conservation of, apply the law of conservation of linear momentum. So it will be written as, that is linear momentum of both blocks before collision will be equal to linear momentum of both blocks after collision. So it will be written as, I can say that m1 v1 plus 0 is equal to, that means here 0 means the linear momentum of second block before collision will be 0 because it is a initially rest position. So here I can say that velocity is equal to 0. So that means m2 times of 0, that will be 0, will be, now here I am writing right side, so it will be written as, that is linear momentum after collision. So I can say that m1v plus m2v. So now next step is substitute the value of data, that is m1 and v1. So I can say that put m1 that is equal to 2 kg and v1 that is equal to, in the question given, 2 meter per second, and also put the value of m2 that is equal to 2 kg in this line. So result will be written as, after solving I will get the final velocity v, that is equal to 1 meter per second. So this is the equation number 2. Now next step is use this value of v from equation number 2 and put here in this equation number 1. So I can say that put the value of v, that is equal to 1 meter per second in equation number 1. So it will be written as, that is maximum possible loss in kinetic energy will be equal to, that is equal to, equation number 1 is, that is half m1 v1 square. That means here I will write the other data also, that is half m1 will be, that is in the question given 2 v1 square, that means 2 square plus 0, then minus, in the parenthesis I will write, that is half m1 v square that means half m1 will be that is 2 v1 sorry v square will be that is 1 square plus half m2 v square, so m2 will be that is 2 and v square means 1 square. So now simplify it, then I will get the maximum possible loss in kinetic energy, that will be equal to, that is after solving value is that is equal to 2 joule. So this is the answer for part A. That means we have to find out maximum possible loss in kinetic energy after collision. So I will get the answer that is equal to 2 joule. Now I am trying to solve part B. So in the part B it is saying that we have to find coefficient of restitution, and there is a condition given, that is actual loss in kinetic energy is equal to half of maximum loss in kinetic energy. So I can say that here it will be written as, that is maximum loss in kinetic energy will be equal to half times of, here put the value of maximum possible loss in kinetic energy by using this answer which is written in the part A. So I can say that 2, here I am putting the value of 2, value that is equal to 2. So after solving I will get the actual loss in kinetic energy, that is equal to 1 joule. Now I can say that if I consider final velocity of first block is v1 and final velocity of second block is, that is v2, then actual loss in kinetic energy will be equal to, that is equal to half times of m1 v1 square, sorry half times of, here first I have to write the kinetic energy in initial condition, so I here writing value directly, so I can say that half times of m, that is mass of block, that is 2 kg, times of initial speed of first block, that will be 2 square plus 0, because the kinetic energy of second block will be, because it is at rest position, so I can say that the kinetic energy of second block will be, that is 0. So here I had written the total kinetic energy in initial condition, and now I am writing the kinetic energy in a final condition, that means after collision. So it will be written as half times of 2 v1 square minus half times of 2 times of v2 square, that means half times of 2 v1 square, that will give kinetic energy after collision for first block, and then minus half 2 times of v2 square, that will give kinetic energy after collision of for second block. So now simplify it, then I and use this line, that is actual loss in kinetic energy is equal to 1 joule. So I can say that it will be written as, that is actual loss in kinetic energy will be, here I am putting the value of 1 at the left side, and the right side will be, after simplifying, value is, that is 4 minus v1 square plus v2 square, 4 minus in the parenthesis I can say that v1 square plus v2 square. So now next step is Now next step is switch the side, so it will be written as, after switching the side I can say that 4 minus parenthesis of v1 square plus v2 square is equal to 1. And now we know that the coefficient of restitution is, if I consider that is equal to E, then I can say that we know formula, that is v1 square plus v2 square will be equal to 1 plus E square multiplied by 4 over 2. So I can say that this is a equation number 2 and this is a equation number 1. So here we have to put the value of v1 square plus v2 square in equation number 2, so that v1 square plus v2 square from equation number 2 to in equation number 1, so that I will get the equation number 1 in term of E, and then after it we have to simplify it. So I can say that put value of v1 square plus v2 square from equation number 2 to equation number 1, so it will be written as, that is 4 minus 1 plus E square parenthesis of 1 plus E square multiplied by 4 divided by 2 is equal to 1. Now simplify it, then I will get the answer, that is E is equal to 1 over square root of 2. So I had get the answer, that is coefficient of restitution is equal to 1 divided by square root of 2. So this is the question, this is the answer of given question. Thank you.